let's talk about AVL trees. So imagine there are these three numbers, and if you need to represent them in binary search tree, then it will be something like this. And for this series of numbers, we will not be getting that exactly, and let's draw that. This will be something like a singly linked list. I'll just draw that so that you'll get it. So this will be a simply like a singly linked list, but in a graphical method, but still it's a linear one. If you need to find the 30th node, we just have to get through all these nodes in order to find the 30th node, and that's not the efficient one as compared to this. So for this we'll be needing AVL tree, and in AVL tree the key functionalities are the rotations. For this rotation we need to find the balance factor, that is this, and for finding out the balance factor we need the height. Well, what exactly is height? Wait, height is the number of child or the sum nodes a particular node can have. So say for example, for this 30, the child node or the sub nodes for this will be null. If it's gonna be null, we'll just initialize directly with 0. So for 20, if you look, the height of that node will be 1. Also remember that if there are elements like 13, 14 or 16, it's going to be inserted once after the 20, so it will be on its left of the 20. So this 13, 16 will be on the left to the 20, so the height at that time will be 2. The maximum of the left or right will be given to the node's height. So in this instance it will be 1. So for 10 the value will be 2, and that is how the height of the node will be calculated. And for the balance factors, if you look, we always go from the bottom to the top, because this all will be working only with recursive functions. So only the child node will be executed first, and then the parent node will be recalculated based on the nodes that are being added to its child. So for 30, if you look, the balance factor will be the height of the left subtree minus height of the right subtree. Since there is no height for this, so the balance factor for this will be 0. Now for 20, if you look, height of the left subtree is 0, but the right is 1, so the balance factor will be minus 1. For this it will be minus 2. Now if you look, balance factor can only range between minus 1, 0 and 1, and if it is less than minus 1 or greater than plus 1, then we should perform rotations, and in order to perform those rotations we need to find whether the numbers are less than minus 1 or they are greater than plus 2. I mean greater than plus 1. So in here the minus 2, it is less than minus 1, so we should do some rotation. If you look closer into the formula, you can see that something on its right is gained more than on its left. So there are more elements on its right, so you should perform the rotation on its opposite direction, that's it. So LL, right, since it's negative, so you should perform the rotation on its opposite direction in order to get that 20, 10, 30, that's it. So this is all it's about the rotation. It's as simple as that. So if you just look 30, 20 and 10, it will be just the quite opposite, 30, 20, 10. So 30 will be with the balance factor of 2, 20 will be with 1, 10 will be with 0. And if you just look, the rotation will be the quite opposite, RR, because left will have the less balance factor for 30 will be 2, so we just have to make the rotation on its opposite direction, that is RR, pure RR. When will it exactly be as LL or RR is the sense. If the diagram is in a linear, like a straight or something, you can just remember the way how you want it. At that time we will be performing pure rotations. Now let's just tweak this a bit. Now 30, 10 and 20, I don't know exactly which kind of rotation it is, but it is exactly the mixed rotation. We'll just go with that. 10 should be here, 20 should be here, so something like this, pretty good. We'll have something like that. So if you look, we'll just rewrite those height. For this it will be 0, for this it will be 1, for this it will be 2. Now the balance factor for this will be 0. Balance factor for this will be minus 1, because height of the left is 0, right is 1, so minus 1. And then for this it will be height of the left will be 2. so 2. That's it. It has nothing on its right, so we'll just go with 2. If you look closely, this is not a linear node representation, though it's imbalanced, but still it's not a linear form. It's just in a bit of like a lesser than symbol, maybe. So for this, the condition will always be the same. Since it's 2, it's positive. So if it is 2, it is not a condition for balance factor. And since it is way on its left, so you should do the rotation on its opposite direction. So it will be R. One will be the R, the other will be L. Because it's not a linear one, we will not be performing a pure rotation, but the mixed one or L rotation will be done. So if it's just 10 will be with 10 will be rotated on RR, and the 30 will be rotated on its left. So when you look into the code snippet, the complete code snippet, you will be understanding it to its core. But I'll just make that as the next video. I just made myself that I should explain this in 5 minutes. That's why I did. And the same goes for the LR rotation. I hope it's just if you do this -2, if it's going to be -2, it should be, the condition will change for this the whole, but I can't able to say that in this 5 minutes. But I hope that you will be able to find it out. You just mismatch those group of that 3 numbers. If you just mismatch and if you try it, you will just get it definitely. So I hope this helped you and you made some understanding from this 5 minutes. Watch you in the next one.